So we're basically going to apply this formula 2 more times. Example C is a little bit different, so you might stick around for that one and fast forward to this one, or pause and try and do this one ahead of me. We have a quadratic. One side's equal to 0. I'm going to use the quadratic formula. So I want the value for a. If there's nothing in front of x squared, but the x squared is there, the value for a is 1. B is going to be equal to 3 again, okay, and c equals negative 2. So again, we're just looking at the x squared term to find a, the x term to find b, and the number that has no x's to find c. I do want to figure out that discriminant, so b squared minus 4ac is what I'm going to evaluate. I'm going to square b in my head. So it's a coincidence, but once again the b value is 3, so b squared is 9, minus 4 times, excuse me, every video, a, c. I would put this into a calculator. 9 minus 4 times 1 times negative 2 would equal 17. So that's what will go underneath the square root symbol. X is going to equal then the opposite of b all over 2 times a, the whole thing over that, plus or minus the square root of that number I just figured out. I'm pretty sure this is my answer. The one thing I do want to double check is I want to think about these perfect squares and see if any of them go into 17 evenly, because maybe I can simplify that square root symbol. But none of them do, so that's my best answer. That's an exact answer. Now what makes question C a little bit different, whoopsie doodle, is that it's not equal to 0. And this formula only works if one side of the equation is going to equal 0. So what I'm going to have to do first is get one side equal to 0. So one side's got the x squared plus the 4x. The other side has a 6. Let's make this side equal 0 by subtracting 6 from both sides. 6 minus 6 will make this side 0. I want that. And then there's no like terms over here. So we're going to be left with x squared plus 4x minus 6 equals 0. It's really important that we move that 6 over because it affects the value for c. So now that I have it in the correct form, where one side equals 0, I can see that a equals 1, b equals 4, and c equals negative 6. Had I not gotten one side equal to 0, I'd have c equal to positive 6, and then my work would be incorrect. So moving along, x is going to equal the opposite of b. Oh, wait, Mr. Depsic, don't you always find the discriminant first? Yes, I do. Thank you for reminding me. We'll do b squared minus 4ac, which in this case, b is 4. So that's 16 minus 4 times a times c. And when you put all that stuff into a calculator, 16 minus 4 times 1 times negative 6, you should get a 40. You really should double check that you're going to use the calculator correctly and make sure you're getting these values, because there's no reason to get this stuff wrong, but a lot of kids do make small calculator mistakes. Figure that out now. So if you haven't been going along and getting your calculator out and doing these things, I really suggest that you do that, just so you know for sure that you're doing it correctly and you can correct any mistakes you might be making with a calculator. So x is going to equal the opposite of b plus or minus the square root of that number we just figured out. That whole thing will be over 2 times a. Now, here's the thing that also makes this particular problem a little bit different. As I go through my perfect squares, and I think if any of them are going to go into 40, I do see that 4 does go into 40. So there's like a little side note, we can take that, we're going to focus just on this part of things right now for a second. There's a radical 40 here. Well, I know that the square root of 40 is the same thing as the square root of 4 times 10. Right now I'm accessing a totally different file of my brain. I'm going back to standard 2.1, the first couple pages of the note pack. Simplifying radicals. So everything else in blue I'm not worried about. It's there, whatever. Root 40 is 4 times 10 is the square root of 4 times the square root of 10. And the square root of 4 is 2. Oh my gosh, I wish I could just write a 4 and not have the pen turn it into a 9 every single time. That'd be great. So it's 2 radical 10. So what I actually have here is this stays the same. This stays the same. But that becomes 2 square roots of 10. And then I can go even a little bit further. Because what we'll do next is we'll look at all the numbers that are outside of the square root symbol. I don't really care what's inside the square root symbol. It doesn't matter to me. It's a weird number. I'm not going to worry about it. But if I focus my energy on all these numbers that are outside that radical, they happen to have a common factor, I'm going to divide out that common factor. And they're all even numbers, so they can all be divided by 2. And if I divide out the common factor, negative 4 divided by 2 becomes negative 2. This would become a 1. So it's going to be 1 times the square root of 10. I'm not going to write the 1 down. There's no reason to. And then the whole thing would be divided by 1. But again, when you divide by 1, there's no reason to write it down. So as I said in class, if you're doing this stuff, this answer over here is good. Like, this shows me you kind of understand the basics of how to apply the quadratic formula. This answer is better because you're showing me too that you understand that radicals need to be simplified sometimes. And you simplified it. And then this is the best answer because it shows that you also remember how to reduce fractions, which is really all that's happening here. When I'm going from this move from the better answer to the best answer, I'm really just using the same skills I learned in 4th grade when I learned how to reduce fractions. Think of 4 over 2 would just be 2, and 2 over 2 would just be 1, and we're not going to put the 1 in front. So I hope this helps you guys recap stuff and understand what's going on. If any part of this is not making sense, really think about what about it's bothering you. But at the end of the day, I would say if you can look at a quadratic and you understand how to find A, B, and C, you should feel good about that. If you understand how to find b squared minus 4ac, you should feel good about that. And if you can take this value you found and then put it into the formula, you should feel good about that. It's kind of like 3 steps. Identify a, b, and c, figure out the value of b squared minus 4ac, and then put all the stuff into the expression. It doesn't feel like you're solving an equation, but you are. This answer, if I could figure out the decimal approximation of this and plug it into here, it would make this equation true. So that's all I got for you guys. I hope that's helpful. Yeah, good luck.